Okay, welcome to Algebra Cafe. This is our first lesson, and I got this sweet new notebook with this Teo Yasmin on the front. Okay, so you will be graded on notes, and the guideline is just to write down what I write down. We're going to review a little bit of a few things about linear equations, and the first thing you need to know is the three forms of linear equations. All right, for slope-intercept form, remember that the m is the slope, the b is the y-intercept, that's why it's called slope-intercept form. This is point-slope form. And again, the m is the slope. And the y1, x1 is a point. We'll do a couple examples there in a minute. This last form is standard form. And traditionally, the a, b, and c are integers there. Today, you're going to be using your notes to complete the linear practice sheet. So I'm going to go over just a few of the ones that I think might be sticky. The first thing I want you to see is that on this problem, it says be careful with the scale. So notice if you choose, say, this point and this point, you can label them. This is wait a second, that's 500. 1, 2, 3, 4. All right, so this is 100, 200. So this is 1, 200, and this is 2, 100. Another thing we should add to our summary notes is the slope formula. I'm going to use the slope formula in an example because I've got 2 points here, 1, 200, and 2, 100. I'm going to label them x1, y1, x2, y2, and then I can find the slope by doing y2 minus y1. And that goes up here in the first part. And then in the denominator, I'm going to have the x2 minus x1, and that goes here in the denominator. So the slope of that line is negative 100. That same strategy you'll use to write equations of other lines. So this equation, of course, is not finished. I haven't finished it for you. You've got to take into account that this has a y-intercept here. Notice that on this problem, we have points on this line, but it's really hard to see the y-intercept. And that's when you're going to want to use different equations of lines. For that one, you might want to use something like the point-slope form. So let's do an example with that. Let's suppose that you have 2 points. You're just given 2 random points, maybe like 2, -8, and 5, -14. We can find the slope just like we did in the previous problem. So x1, y1, x2, y2. So my slope is -2, and I can use that to write my equation. Because I now have a point, actually I have 2 points, but I can choose either one, and I have a slope, the best form that's going to be the most useful for me is point-slope form. I don't have a y-intercept, and standard form is not going to be that easy right now. So I'm going to go ahead and choose this as my point, but I could have chosen this one. So the formula says y minus whatever y1 is equals the slope times x minus whatever the x is. So let's just be clear about what we're putting in which blank. This is the x coordinate we're using, and we're going to put that down here. This is the y coordinate that we're using, and we're going to put that here. And we've got our slope right here, and this goes in this part of the equation. So here I've got -2. Here I've got a -8. Since it's minus a -8, I'm going to go ahead and change that to a +8. And for this one, it's a +2, so it stays at -2. And there's my equation. Now you can convert that to slope-intercept form if you would like to distribute and combine like terms and such. But you can also just leave it like that. The last example we're going to do is with parallel and perpendicular. So remember that parallel lines have the same slope, perpendicular, opposite reciprocals. So if we have a line something like y equals -3x plus 5, and that's my line, parallel line would have m equaling -3, perpendicular line would have m equals the opposite reciprocal, so it's going to be positive, and we have to flip it over. This is like 3/1, 1/3. So let's suppose you need to write a line that's both parallel and perpendicular. And it has to go through a point, 9, 1. So let's first write the parallel line. We know that the slope has to be -1/3. We know that we have a point, which is going to be 9, 1. So we can go ahead and start. I see that I have a slope and a point, so I probably am going to do point-slope form. But I'll also do an example of how you can do this exactly straight in slope-intercept form. So this is going to be my x1, this is going to be my y1, y minus 1 equals -1/3 x minus 9. So that's one way to write the equation. The other way is you start off with an equation like this, and then you have to find the b. You use this point. So we're going to put the x value that they've given into the x coordinate, and we're going to put the y value that they've given into the y variable. And that's going to help us find the b. So just by logic, I can tell that the b is going to have to be 4. I can find it officially by doing this. B equals 4. And now I've got to go ahead and write the equation, the full equation, which is y equals negative 1/3 x plus 4. Let's come back over here and make sure that this is really the same thing as this. So I'm going to go ahead and distribute. When I distribute, I have to make sure that I do that to both things. Negative times a negative makes a positive. And indeed, both ways give us the same thing. It's also fine for you to just report this as the final equation. So part B for a problem like this is often to do the same thing but with a perpendicular line. And then since the slope of the line is negative 1/3, we know that a perpendicular line is going to have a slope of a positive 3, and we still have that point 9, 1. So our process is going to be exactly the same, except we're not going to put in a slope of negative 1/3, we're going to put in a slope of 3 and solve the equation just like we did.